application with it's already been started. Okay, students. Let's see if this is going to work. I'm now going through PowerPoint. Smart Recorder has failed 5 times on me right now. So now we're trying PowerPoint. All right. I'm going to split this into 2 so I don't waste my time talking in case this one fails. So I'm going to do problems 1 and then 6 through 10, and then 2 through 5 are on a Smart Notebook screen. All right, number 1, the ratio of angles A and B are 8 to 22. What is the measure of the smaller angle? Well, we see angles A and B form a linear pair, which means they're supplementary, which means they add to 180. We know when we have a ratio here with our column, we know we'll put an x behind it or some variable behind it. So we have 8x plus 22x is 30x, and we know they add to 180, so equals 180 divided by 30 on both sides, and x equals 6. We want the smaller one, so 8 times 6 is smaller, 48 degrees. All right, number 2, determine the most precise name of the quadrilateral. So you use your quadrilateral hierarchy theorem if you don't know what your definitions of your different shapes look like, what has to be true about them. Plot the points. We see that the closest this looks like it could be as a trapezoid if these 2 segments are parallel. So I need to test that. I can't just assume from looking at it. I need to actually find the slope of each one. So you see I call this one segment 1 and this one segment 2 here. So segment 1 slope, I want up 3 and right 3. Changing y over changing x, 3 over 3 is 1. For this one I want up 4 and right 6. So that reduces to 2/3. 2/3 is close to 3/3, but it's not the same. So therefore these are not parallel lines, and therefore it's not a trapezoid, and so the only thing we can call it is a quadrilateral, the most general. Remember on the bottom the square is the most specific. Alright, let's see if we can zoom in a little bit more there. Okay, maybe that is easier to see for you guys. Okay, what is the exact perimeter of the triangle? Okay, the reason I have drawn the right angles around them is because I'm finding the length of each side here. Okay, so I'm going to use Pythagorean theorem. You could use distance formula, which is the same thing, but when we go to number 9 and find the exact area, drawing these triangles are going to be useful in doing that already. So that's why I'm going to use Pythagorean theorem, because it'll also be used on number 9, the triangles that I have drawn here. So plot the points. Okay, draw your right triangle to connect them. Obviously each side is the c in the Pythagorean theorem. A squared plus b squared equals c squared. So to get down to c, I must take the square root of a squared plus b squared. So the square root of 9 squared plus 1 squared is square root of 82. That does not simplify. If it did, I would. Here we have a 7 and 7. I should recognize that as an isosceles right triangle, which means it's a 45, 45, 90, which then means the hypotenuse is root 2 times longer than the sides, the legs. So that automatically makes it 7 root 2. Okay, but if you didn't know that, you'd have 49 plus 49 is 98. The square root of 98 breaks down to square root of 49 times square root of 2, and the square root of 49 is 7. So you still get the same thing. And last, I have 2 squared plus 8 squared. 4 plus 64 is 68. The square root is 68. I have to check my perfect squares to see what goes into it. 4 goes into it. 4 times 17. The square root of 4 is 2. So I get, and 17 does not break down, so I have 2 root 17. I check none of these have the same radical, so I cannot combine them, but that's also why I need to reduce them. So if they did end up with the same radical, I would have to combine like terms by adding their coefficients together. Okay, so these are all 3 separate. Exact, whenever I see exact, I should be thinking radicals in my answer. No decimals. I can't put square root of 82 in the calculator and decimal down. Okay, you get marked wrong. You're not following directions. So put a parenthesis around the whole thing and use a U for units because it's a single length. Okay. Number 8 now says take that answer and plug in your calculator. Now round that to the nearest tenth and then put your U for units behind it. Number 9 now says find the exact area. We just found the perimeter with the area, so we're going to take the area of the rectangle that we've now drawn already around it and subtract off region 1, 2, and 3 from it, and that will give me the area of the triangle. So length times width or base times height, I get 8 times 9 is 72 square units for the whole rectangle. And now I have to subtract off the area of each of these three triangles. 1/2 of 9 times 1 is 4.5. 1/2 of 7 times 7 is 24.5. And 1/2 of 8 times 2 is 8. I add those together and I get 37. 72 minus 37 is 35. And this time it's square units because we're finding area. Anytime it's area, it's square units. Okay, number 10 and 11. What is the exact distance that 2, -6 is from the origin? So I was testing you to see if you know what the origin is. 0, 0. I went right 2 and down 6. Now I can have my right triangle there, draw a right triangle, and do Pythagorean theorem again, just like we were doing up here. So 2 squared plus 6 squared, square root. Square root of 40 breaks down to square root of 4 times square root of 10. Square root of 4 is 2. So 2 root 10, and then it's units again because I'm finding distance, not area. And remember, volume, the next module is cubed. All right, determine the type of triangle, isosceles, right, scalene, or a combo of these three words. If it's going to be a combo, it's going to be an isosceles right triangle or a scalene right triangle. Okay, remember isosceles means at least 2 congruent sides, so 2 or 3. So that includes an equilateral triangle. Scalene means no sides the same. Right angle is another word for perpendicular, and we learned from perpendicular in our last test. So whenever I think perpendicular, I need to be thinking slope, and I need to be thinking the words negative reciprocal. So I go ahead and plot these 3 points they give me for the triangle. Okay, and I have to find the length of each one to see if 2 or more are the same, or if they're all different for scalene. So I have, again, Pythagorean theorem, just like we did up here. 7 squared plus 2 squared is square root of 53. Here we have a 3, 4, and then this makes it 5, Pythagorean triple, or 9 plus 16 is 25, square root of 25 is 5. And lastly, we have 5 squared plus 3 squared, take the square root of that, and that is square root of 34. So these are all different, so it automatically makes it scalene first off. Now the question is whether it's also right or not. So this is not close to 90 degrees, that's not close to 90 degrees, but this is fairly close to 90 degrees. So I need to check to see if these two slopes are negative reciprocals of one another. If they are, then it's also right. If it's not, it's just scalene, because it would not be a right angle. So I found I called this segment 1 and this one segment 2. So the slope of segment 1, I went up 4 and left 3, which is negative 4/3, or you could have gone right down 4 if you wanted to, and right 3, and it also give you negative 4/3. Remember, changing y over changing x. Well, what's the negative reciprocal of negative 3/4? Or negative 4/3, I meant. It's positive 3/4. So if this segment here is positive 3/4, then they are right angles. That is a right angle right there, I meant perpendicular. But what is it? It's up 3 and right 5. So it's 3/5. 3/5 is close to 3/4, but it's not the same, so they are not perpendicular. So the answer is only scalene. All right, I'll go ahead and stop there for the first part here. Let's see how it works.